Okay, we've been talking about hyperbolic functions, and in this video, we're going to learn how to take derivatives of hyperbolic functions. So all of the derivative rules that you've used before are still in play. That is the power rule, chain rule, and things like that. But now we're tossing into the mix these hyperbolic functions. So if you look at this very first problem, you might notice that it's a natural log derivative. We know the derivative of natural log, but it's also a chain rule, and it's got a couple of chains involved here. All right. So if I look at this, I know that I'm going to take the derivative y prime, and it's going to be the derivative first of the natural log function, which is 1 over u. So in this case, it's going to be 1 over the sech of 9x plus 7. Now I'm going to multiply it by the derivative of the inside. Well, by this chart here on the side, the derivative of sech is negative sech tanh. Okay, so I'm going to take the negative sech of 9x plus 7, multiply it by the tanh of 9x plus 7, and then I have to follow the chain rule and multiply by the derivative of the inside of the inside. The derivative of 9x plus 7 is simply 9. So there we have our 9. Okay? And so there's nothing more really to this problem other than to try to simplify. And so we should notice that the sech we get rid of through division, and we actually no longer have a fraction. In this case, our y prime being negative 9 multiplied by the tanh of 9x plus 7. Okay, so there is our answer for this very first hyperbolic derivative problem. So really nothing to it. I mean, it's very similar and straightforward to what you've been doing before. All right, so let's go ahead and take a look at another problem. This one will involve another chain rule, of course. So this one is going to take a look at the sinh squared of 3x. And so what we're going to do is we're going to rethink the way that this looks first so that we can apply the chain rule. Okay, so here is the way that the function looks, and now let's take the derivative. So we're going to take the derivative of the outside first. So we're going to bring down this power 2. All right, we're going to have 2 times the sinh of 3x, and we're going to subtract 1 from the power, so it's to the first power. And now we're going to multiply it by the derivative of the inside, which the derivative of sinh in this case is cosh. So the cosh of 3x. All right, and then we're going to multiply it by the derivative of the inside, which the derivative of 3x happens to be 3. And so I think we're good here. We end up with something like 2 times 3, which is 6. And then we end up with sinh of 3x cosh of 3x. And so that right there represents the derivative of this chain rule problem, again using hyperbolic functions. So this right here is our derivative. All right, and let's take a look at one more example here. We're going to call this one number 9 in our video, and this one right here is y equals negative 4t cubed tangent, or I should say tanh of 1 over t squared. All right, so I'm going to have to rethink again the way that this looks just a little bit, and the only thing I'm going to change is what's inside the tanh, because we're going to need that in terms of exponents that we can work with. Okay, but other than that, we should start seeing we have a product rule that we're going to apply. So when we look at the product rule, I'm going to write u and I'm going to write v. So u is negative 4t cubed, v being the tanh of a t to the minus 2. And then let's go ahead and take our u prime, which is going to be here a negative 12t squared, the derivative of that. And then the derivative of tanh, based on what we've known from the chart up above, is that it is sech squared. Okay, so v prime in this case is going to be sech squared of t to the minus 2, but now I've got to multiply it by the derivative of that t to the minus 2, which is going to be a negative 2t. All right, let me scoot this over just a little bit. Negative 2t to the minus 3, and it looks just like that. So now that we've got all of that, I can put everything together to try to find this derivative y prime. All right, so what does it look like? It's uv prime, so negative 4t cubed times, okay, negative 2t to the minus 3, and then it's going to be sech, and I think it's okay to write it as 1 over t squared, which is originally what it was when you have that t to the minus 2. Okay, and then we're going to add, okay, vu prime, which is going to be a negative 12t squared times the tanh of t to the minus 2. All right, now that I'm doing this, I'm going to try to see if I can combine any like terms to this multiplication that I went ahead and obtained. The negative 4 times the negative 2, of course, is going to give me positive 8. But the t cubed and then the t to the minus 3, you add the exponents. So what ends up happening is we end up getting rid of this because you end up with t to the 0 power. So you're going to have 8 times the sech of 1 over t squared. And then you're going to subtract 12t squared tanh. And again, 1 over t squared. I should have fixed that on the last part, but that's okay. All right. Other than that, there's not much more to simplify. And we have our derivative for this problem. So really nice applications, really, of these derivative rules for the hyperbolic functions. And it really puts things into perspective, I think, in terms of how easy it is to apply them and how it's really closely related to what you might have been doing when you were talking about the regular sine, cosine, and tangent. All right, slight differences in terms of the rules, so please do make note of those, but otherwise relatively straightforward and easy to follow. As always, I hope this video was helpful, and remember, like and subscribe.